Hi, hello everyone. In the previous video, we already learned how to find domain and range from the graph that we sketched. Now, in this example, we continue with the question regarding absolute function. So before we find domain and range, we have to sketch the graph first. So for absolute function, you need to find the point of x where the function changes between positive and negative definition. In this case, we equate x plus 2 with 0, so we get x equals to negative 2. So the positive definition is defined for x greater or equal than negative 2, where for negative definition, it is for x less than negative 2. So, as we discussed in the subtopic 5.1d, the shape of the absolute function would be like this. That is starting at negative 2. So, this is for negative definition, which is less than negative 2. And this is for positive definition. And the intercept would be at 2, as we find out here. So the graph would be like this, and from here we can find out the domain and range. So for the domain, more or less it is like a quadratic function before, that is for every numbers of x, which is x can be positive or negative numbers. Where for range, also like a quadratic, since here we start at 0 and above, so our range would be start at 0 and towards the positive infinity. For question D, the function of g given absolute of 3 minus 3x plus 2. So in this case, we have to check the definition. So as you can see right here, we have positive and negative definition. So the first one will be negative definition, and the second one would be the positive definition. I say positive definition because when we expand the negative, it will come out to be 3x minus 3. Okay, so we can change at negative outside 3 minus 3x to be 3x minus 3. Okay, so negative definition, of course, it is for x less than, and this one for x greater or equal than. So what is the changing point here? So this one we will check right here. So 3 minus 3x we will equate with 0. So it comes out that x equals to 1. Okay, so the changing point here is at 1. So as you can see here, the shape of the graph should be something like this, right? Which is at 1. This is at 0. So I change here to be at 1. Okay, at 1. But in our cases, the function has the constant 2 outside. So the lowest point here cannot be at 0. So it must be up by 2. Right? So our new graph should be like this. That is, the lowest point must be at 2. So this is also still at 1. Right? So before this, the intercept here is at 3. Okay, because 3 minus 3 at. So this is 3. So since here we already up by 2, so the intercept here would be at 3 plus 2. Yes, 5. So our new graph should be like this. Okay, so make sure you sketch your graph properly. So your graph, yes, should be like this. So don't forget to label y and x-axis. So this is what the graph that we get, and from here we can obtain the domain and range easily. So the domain remains same, which is all real numbers. Okay, while the range, it is no more start at 0 because we already, the graph has a constant 2. So now we start at 2 and above, which is we start with 2 and towards positive infinity. So this is the range that we get from this example. For question E, 5 minus absolute x. If you remember the basic shape of the graph, when we have negative outside, the graph would be like this. Okay, so here absolute x means x equals to 0. No need to equate with something, just directly x equals to 0. So straight away we find out that the modulus x would be x and negative x. So this is for x greater or equals to 0, and this one for x less than 0. So our y-axis at the same point, so it is right here. Okay, so this is the shape of our graph. Because of the negative outside, it has a peak at 0, and apart from that, we also have 5 outside. Remember the previous example that is going for D, when we have constant, the graph will shift upward, right? So our graph right now would be like this. So shift upward by 5. So now instead of 0, it will intersect y-axis at 5. So this is the graph that we get from this question. Okay, so from the graph we'll find out the domain and range. So the domain remain the same, nothing changes, even though the function is changed, which is x is valid for all values of x. And for range, since now we have peak at 5, so remember the quadratic, the set one, this one we call it maximum, right? So here also we have maximum at 5. So before that, it must be from negative infinity, right? So this is the range for these questions. So this is the example, and for the next video, we'll discuss how to sketch and find out domain and range for set function. Thank you.